Alright, so when I look at example 3, I see that it's given that LM is congruent to LN. So I'm going to mark those congruent. And I know that LP is perpendicular to MN. So I'm just going to write right here that those are perpendicular. Alright, so what can I infer using that information? So I know that LP is perpendicular to MN, and what I know about perpendicular lines is they form two right angles. So, let's see, I'm going to say the angle LPM and angle LPN are right angles. And I know that because of the definition of perpendicular. Okay, I also know that this is congruent to this because that's the reflexive property. So LP is congruent to LP. And when I look at this, I see it's reflected, so that's why LP and LP, not LP and PL. Alright, so let's see if I have enough information. So when I look at this, I see a side and an angle, which that's the bad word. But there's something special about this triangle, is I do have two right angles, and when I look across, I see that I have a hypotenuse and a leg. So I am going to be able to conclude LPM is congruent to triangle LPN, and I'm using the hypotenuse leg theorem. So here is my two-column proof. And that's given. Alright, and then my infers, LPM and angle LPN are right angles. And I knew that because I used that definition of perpendicular. I also said that LP is congruent to LP, and I used the reflexive property for that. And finally, I was able to say that triangle LPM is congruent to triangle LPN, and I used hypotenuse leg. And when I look at this, I see it's a reflection.